Okay, so we're getting you ready for the test. It's called Communications Number 2, and it's going to have a lot of this kind of stuff on it. It's about polynomials. What do we know so far about these things? We know things about the roots. The roots are the same as the zeros, the same as the x-intercepts and all that stuff. We know that when you have a degree, that whatever the degree is, that's how many answers or roots there are. You know about the end behavior, that basically if it's going up on the right and down on the left, that would have to be like a third degree or a fifth degree. The ones that are odd degrees go opposite directions. We know if it's going up on the right, that it has to be starting with a positive. All right. The y-intercept is something that you should be able to find in an equation. It's the number when you stick in x equals 0. It's the number you get. So if I gave you an equation like this, you should be able to say, oh, I know this is a parabola because it's got a square in it, right? You should be able to say, I know that this negative means it's an upside down parabola, right? And if nothing else, you'd know that that negative means it's going down on the right-hand side. You'd know that the parabola has been moved 4 to the left and down 7, and that this 2 means that it's stretched twice as high or low, stretched up, down, vertical stretch. All right, so if I gave you these clues, there were 3 roots, and they are 2 and 3 and -2. It's a third degree polynomial, and it's up on the right. You should be able to make a little sketch of it. Try making a little sketch from what I just told you there. It's a third degree, so you know something about the end value. There's 3 roots, and it's up on the right. Sketch. Make a little picture. All right. First thought would be 2, 3, and -2. Here's 2. Here's 3. Here's -2. Has to be touching all those spots. Degree 3 just means that it's going to be one side's going up, one side's going down. And it says up on the right, so it's going up here. So maybe it's like that. And then I guess it could be like this. That's one option. In fact, I think that's pretty much got to be it. Now, it could be stretched up higher or lower based on, you know, if you wanted to make these. It has to be going up here at the end. It has to go through that dot. It has to go through this dot. Here's one that's been stretched more. I didn't say anything about a stretch factor. So. All right, then how about this? What's the equation got to look like? Well, it always starts with a y equals. And it actually could have a y minus something, but we're not going to go there. We're going to say y equals, and then we usually make 3 sets of parentheses for the roots. And how do I make a root 2 happen with a parenthesis? You say x minus 2. And how do I make a root 3? X minus 3. And how do I make a root of -2? X plus 2. And then it's going up on the right, which is positive in front. So this is positive in front. Notice there's no negative there. All right? All right, see if you can sketch me what that would look like. The red one. 2 roots. It's degree 3, and it's up on the left. Make me a little picture. I didn't say where the roots were, so you got a lot of latitude there. Up on the left means it's got to be going like that. If it's degree 3, what's it doing on the right? It's got to be going down over there. And in between, it's got to touch. Well, actually, there's a lot of options. It could be like this. Cut through, cut through, cut through. That would work. Oh, you're right. That would have 3 roots. Oh, but it's possible. It's possible. I just forgot that this is one of those where it's got a degree 3, but only 2 roots. You might be thinking, well, one must be imaginary, and it can't be. Imaginaries only come in sets of 2. And therefore, how can we have one of my roots count for 2? Boing. Bounce. Two plus 1 is 3. You get that? It's one root, but it's a double root. It's kind of cheating. It's at -3 there. Could be at anything, but that one spot that it hits, and it hits another spot over here at, let's say that's 4, then that would satisfy it. It's got 2 roots, but its degree is 3. 2 for this, 1 for that, and it's up on the left, so everything qualifies. There'd be another way to write it. Got to start going up on the left, but maybe it's not a bounce there. Now you have to have a bounce, but coming from the bottom, it'd have to bounce like this. Boing. That would also work, wouldn't it? Okay. All right. There's one thing you need to know. Write me 3 forms of the equation. Here is a nice little practice problem. You got an upside down parabola, and I can write an equation for that pretty easy if I just look at the 2 and the 6. You should be able to write me an equation like that. Write me the equation for it. Y equals zip zip. Do you have x minus 2 and x minus 6? All right, well, you're completely wrong. There's one more really important thing. Does anybody notice it? Ah, you noticed it. Why is there a negative? Because it's upside down. On the right-hand side, it's going down, and so I need it to be negative right there. Ooh, that's so easy to forget. Forgot it in one of my classes today. So don't feel bad if you forgot it. All right, now I'm going to go multiply this out. I'm supposed to get 3 forms of this equation. So if I multiply this out, that'll give me general form. Y equals, I'm going to wait for that negative. First I'm going to multiply the parentheses together. X squared minus 8x plus 12. And then I'm going to stick a negative on everything because there was a negative out front. Negative here, change that to a positive, change that to a negative. And there's my final answer for general form. And what's the other kind of form? Vertex form. You can say y equals, and then put something like this, and then put the vertex here and here. What's the vertex on this puppy? 4, 4. So I'm going to put a 4 and a 4. Which of these is actually a positive 4? The one on the outside, and the one on the inside is a minus 4. It's counterintuitive. And now, one more thing. It is still upside down, isn't it? So where do I signify that? With an. Okay? All right, that was a tough one. This one is similar, but even a little tiny bit tougher because it's been stretched. Give that one a try. Start by writing the factored form of it. And don't forget, it's been stretched. Okay. Hopefully you notice you have the 2 parentheses just like before, and you have an x plus 4 and an x plus 2, because this negative 4 here needs to solve this, so I need it to be positive 4. So when I put the negative 4 in right there, it'll make it 0. That's why they call them zeros. Okay. And then I got to factor in that this thing is upside down, and that means I need a negative on it. But there's one more thing. It's been stretched. It's twice as tall as normal. Instead of going over 1 and down 1, it's going over 1 and down 2. So it's -2 out in front of the whole thing. How many of you caught that? Raise your hand if you had that right. Good. Next part, I actually multiply it out. I multiply this part out first, and then I multiply everything by -2. So y equals x squared. Slap a -2 on it. -2 x squared. Then outside and inside would be 6x, slap a negative 2 on it, negative 12x. And the last would be 4 times 2 is 8, slap a negative 2 on it, negative 16. You get that? That's general form. And the last part is the vertex form. Y equals parentheses with an x and a squared in it there. There's your kind of general open parabola ready to make vertex form. Here's where the vertex goes. And the vertex in this case is negative 3, positive 2. So I make positive 3. And it's positive 2. And then it still needs to show that it's upside down. And it still needs to show that it's a factor of 2. Yes? You're right that it's been reflected. Wait a minute, you said over y. I think you mean up and down. It was an up-down flip. It wasn't a left-right flip. It was an up-down flip. You know what I mean? Like a normal parabola looks like this. So this parabola is upside down, right? So it's flipped up, down. That's a flip over which axis? Flip over the x. You could actually flip it left, right, and it wouldn't have made any difference. You know what I mean? Because when you do a flip on a parabola that's like this, and you flip it this way, it looks identical to each other. So, okay. Anyway. So now, that's like the second topic that you need to know how to do. This one's just kind of a little bit of a review of what we talked about before because it was really important. That negative out in front, does that mean something about the left side or the right side? Ha! Put it up on my desk. It's a really good game, but not a good time to be playing it. All right. Is that Stone Loops of Jurassica? Is that what that was? Okay. I thought it was Stone Loops. All right. We'll have a chat about that later. This tells me the right side is heading downwards. All right. How about the degree? That's degree 2. What does that mean about the left and the right sides? They're both the same. They're either both down or both up, right? And in this case, they are both down. And then the lead coefficient being a 3 means the thing's been stretched. And the fact that it's a negative 3 is the whole upside down thing. And then the y-intercept, don't ever forget, it's right there. Y-intercept is where x is 0. Making so much noise. I'm having mic issues. There, much better. Thank you. Okay, so now, polynomials, real or not. There are some that are not legitimate here. One of these things is not like the others. That was an old song they used to sing on Sesame Street. Did you guys, any of you watch Sesame Street? Did you remember the count? You would like count out the number for the day, like 1 vampire, 2 vampires. You'd count it out to whatever the number was. Maybe your generation was more. How many of you guys remember Teletubbies? Remember? Can anybody name some of them? Yes. Go ahead. Poe is one of them. Yes. Tinky Winky, Dipsy, La La. All right, good, good. Remember the big bright sun and the little baby laughing? All right. Wasn't terribly educational, but I remember that from my kids too. Well, the one of these things is not like the other song came to mind because that is the only one that's actually legitimate. This one's not because you're not allowed to have a square root. Why? Because it's really x to the 1/2. The square root of x means x to the 1/2 power. And if x is to the 1/2 power, then it has a fraction exponent. Not allowed. Negative exponents like this. Not allowed. Don't forget that. Those are the things you're looking for to see if a polynomial is real or not legitimately a polynomial. All right. That brings up an old topic. What's the square root of x squared? It is not x. I knew I was going to have 4 or 5 people say that. What is it? Absolute value of x. Got to get that through. Okay, because then you'll know if you have this x squared equals 16 and you take the square root of both sides, you'll have absolute value of x is 4, and therefore x is 4 and x is negative 4 because of the absolute value. All right, you got to have that. All right, here's another way to think of it though. Now that we've talked about how square roots are really 1/2 powers, isn't this the same as x squared, and instead of the square root sign, couldn't I do this? Yes, I could. And then what's 2 times the 1/2? You multiply them in this scenario. It's 1, and that's why the answer is x. It's just a different way to show you that the answer is x. But you got to remember the absolute value. Okay. All right, moving on. What order should you do this in?